Okay, so once you have your notebook out, you're going to uh, title today's notes in your table of contents as volume and mass notes. Today's date is 9/28. Our essential question for today: why is it important to know how to accurately measure mass and volume? Well, you're going to need to know for today's assignment how to measure mass and volume. You're also going to need to know for tomorrow's lab. Um, Maybe a little bit more importantly, you're going to need to know how to measure mass and volume throughout this course, and really, you're going to have to measure that in most of your science courses in high school. Um, it's going to be important that you know what mass and volume are and how to measure them for high school, and if you continue on to college, you'll have to know that in college too. Even if you're not a science major in college, you're still going to have to take science classes, just like we make you take science classes in high school. But maybe even more important than that is really people measure mass and volume every single day. You measure your mass every single time you step on a scale. You measure volume um, every single time you're in the kitchen, usually, and cooking, right? Cooks measure volume all the time. Some cooks will actually use a kitchen scale to mass their food. Mass and volume are something that, show up a lot, and so you're going to need some sense of what they are in life. Okay, so what is volume? Volume is the amount of space that something takes up, and we usually measure volume with a graduated cylinder in science. There's other ways to measure volume. Sometimes we use things like a beret or a pipette. Um, uh, Usually it's with a graduated cylinder, though. Um, and so then, um, well, here, let's talk about how you use a graduated cylinder to measure volume. And one thing I want you to notice, look, when you put liquid in a graduated cylinder, it kind of forms a little bit of a bubble on top here. Oh, we can ignore that slide for now. Okay, so when we measure volume, and we have that little bubble on top, we actually measure from the bottom of the bubble. That's the level that we're at. Um, and so that little bubble is called the meniscus. Um, and so you want to measure from the bottom of the meniscus. That's how you measure volume. Okay, so one method for finding volume. Um, you can title this in your notes as Method 1. If you have the length, width, and height of a box, you can measure the volume of that box. And um, all you have to do is multiply the dimensions together 10 times 2 times 5. 10 times 5 times 2, when you multiply that out, you should get 100. And so this box is 100 centimeters cubed because 10 times 5 times 2 equals 100. The centimeters cubed comes from centimeters times centimeters times centimeters. So centimeters times centimeters times centimeters will get you to the unit centimeters cubed. So volume has units centimeters cubed. Okay, a second way that you can use to find volume works for like weird or irregular objects. So this method works if you have a box, but it only works for a box. And there's other shapes that, there's a formula that you can use to find the volume of, but most shapes or most objects have a weird shape and you're not going to be able to like calculate what the volume is. And so we use the method of water displacement. And this was developed by the Greek philosopher Archimedes. So I'm going to tell you a quick story about Archimedes. Archimedes was a philosopher and a scientist and a mathematician and an engineer. And he lived in ancient times. And he figured out um, that you could determine the volume of an object by dropping it in water and seeing how much the water level raises. Now, how did he figure this out? Well, there's a story. I don't know if it's true or not, but the story goes that Archimedes was trying to figure out how he could measure the volume of an object. and he was going to take a bath, and he sat down in the bath, and he saw that the water level rose. And so then the way the story goes is he started running through the streets naked because he was taking a bath, and he started yelling, "Eureka! Eureka!" which means, "I have found it! I have found it!" And so the idea being that he figured out that when he sat down in the bath and the water level went up, that he could use the difference in water level to figure out the volume of an object. So how does this work? You fill a graduated cylinder with some water, or really it could be any fluid. It doesn't have to be water. And then you record the start volume. And then you gently drop an object in the cylinder and you record the new volume. And the change in volume of the water is the volume of your object. So why does it work? Two objects can't occupy the same space. Drop something in water, the water rises. So how do we use this? Well, here we've got a graduated cylinder and then we've got a rock. So we're trying to figure out the volume of this rock. So the graduated cylinder started at 75 milliliters. It ends at 98. So we take the rock, we drop it in the graduated cylinder, and the water level rises to 98. So then how do we calculate the volume of the rock? Well, we're going to do it with subtraction. We just do 98 minus 75 milliliters. That gets us to an answer of 23 milliliters. And so we can see our units for volume are milliliters. Well, wait a second. Didn't I just say that the volume, or that the units for volume were centimeters cubed? Well, a milliliter is a centimeter cubed. They're actually the same thing. So there's two different units for volume. They're exactly equivalent. So milliliter or centimeter cubed. Students seem to like writing milliliters better because then they don't have to remember the little 3. So if you can just remember that these two things are equivalent and then always write it in milliliters, that might be easier for a lot of you. Okay, let's go through some practice problems. So practice problem 1, you're going to try to find the volume of this box. So go ahead, take a minute and try and do that. And then I'll show you what the answer is in just a second here. To solve this, you're going to take 5 centimeters times 4 centimeters times 2 centimeters. 5 times 4 is 20, times 2 is 40, and then remember that this is centimeters cubed. You could have also wrote it. For this other problem, we can see that we've got this graduated cylinder. Try to estimate what the volume of this graduated cylinder is. And if you guess 38, you're correct. Look, this is going up by 2s, so 2, 4, 6, 8, 10. So this went from 30 to 32 to 34 to 36 to 38 to 40. So this is going to be 38 milliliters. So if you guess 39, you probably just forgot that that only works when there's 10 in between, right? In this case, there's only 4 in between. And so that means that we have to be counting by 2s. Okay, last up is mass. Mass is how much matter or stuff an object has. We always measure mass in grams, and we use a balance or scale to measure mass. So measuring mass is a lot easier than measuring volume because you just put the thing on the scale, and then the scale will just tell you what the mass is. We'll talk more about how scales actually do this when we get later in the year and we start talking about forces and springs and when we start talking about electricity. But yeah, mass is a lot easier to measure than volume is. Okay, and then one last little thing. For water, 1 gram of water will have a volume of 1 milliliter or 1 centimeter cubed. And this isn't an accident. It's because when they came up with the unit for the gram, the way that they did is someone took 1 milliliter of water and then he found the mass of it, and that person said, aha, this is going to be my base unit for mass for the metric system. We'll call that unit a gram. So they took 1 milliliter of water, found the mass, and that's where the gram came from. So what should you be doing right now? Open the volume and mass practice and notability, complete the assignment, and submit the assignment to